Okay, so for this circuit, we have to find the resonant frequency and the half power frequencies, the quality factor and bandwidth, and find the amplitude of the current for WO, W1, and W2. So we're given what R should be. So R is 2 ohms, L is 1 millihenry, and capacitance is 0.4 microfarads. Okay, so let's convert that to microhenry to Henry. So that's just 0.001 henries. And this is just 4 times 10 to the power of minus 7 farads. So let's first solve for A. To find the resonant frequency, it's omega O equals 1 over the square root of the inductance times the capacitance. So that will just be 1 over the square root of 0.001 times 4 times 10 to the power of minus 7. And that gives you 50,000 radians per second. So that's the first problem done. Now B, it's asking for oh yeah, wait. Then it asks also, oh yeah, wait. So A also asks for half power frequencies. Well, let's solve for B and C, and then we can find the half power. Sorry, let's solve for B first, and then using B we can solve for the half power frequencies. So let's do B. So it asks for quality factor and then bandwidth. So quality factor, since this is a circuit in series, there's two formulas you can use. You can use 1 over omega O times the capacitance times the resistance, or you can use omega O times the inductance all over the resistance. Both of these formulas should give you the same answer. So let's just go with this one. So 1 over WO times, so wait, so WO was 50,000. Then the capacitance is 4 times 10 to the power of minus 7. And resistance is 2. And this gives you 25. Oh, and a quality factor is unitless, okay? So using the quality factor, we can get our bandwidth. So our bandwidth is equal to the resistance over the inductance. Okay, so it will be 2 over 0.001, which is what is that equal to? That's equal to 2000 radians per second. Now, using this, we're gonna find we're gonna go back to A and solve for the half power frequencies. So there's these two formulas that you can only use when quality factor is greater than or equal to 10. So W1 will be equal to omega O minus the bandwidth over 2, and W2 will be equal to omega O plus the bandwidth over 2. So W2 should always be greater than W1. Okay, now WO was 50,000 minus 2,000 over 2, and let me see what that gives you. Hello, let me use my calculator for a sec. That should give you 49,000 radians per second. And this one, it's 5,000 plus 2,000 over 2, and that should give you 51,000 radians per second. And what you'll notice here is your bandwidth is actually equal to W2 minus W1 as well, because 51,000 minus 49,000 is equal to 2,000. And also, your WO is equal to the square root of W1 times W2. Okay? So those are just some useful formalization now. Now the last part, it asks for to get the amplitude of the current at WO, W1, W2. So the formula to solve for this is a little like long. So it's equal to the current is equal to Vm all over the square root of R squared plus WL minus 1 over WC squared. Okay, VW is pretty much this value. Okay, because it's I mean VM. VM is pretty much this value, 20. It's VM sine WT. Okay, so let's solve for IWO. So it'll be what was the current voltage in? Okay, 20. So it'll be 20 all over the square root of 2 squared plus. So right now we're finding the current for WO, or sorry, the current amplitude for WO. So we'll put 50,000 here. So 50,000 goes in here times 0.001 minus 1 over 50,000 times 4 times 10 to the power of minus 7. Then all of this whole thing is squared. And this should give you, give me a sec. This should give you 10 amps. Now for IW1, it's pretty much the same formula again. But instead we use, instead of 50,000, we use 49,000. And that should give you, give me a sec, 7.035 amps. And then finally we have W2. That should be, instead of 49,000, we're going to use, what was the number? 51,000. Okay. So 51,000. Sorry, minus. Okay. And that should give you 7.106 amps. So these are your final answers.